All right, let's just dive right into this explainer. Today, we're looking at how we can literally engineer our homes to stand strong against the ever-growing threat of wildfires. We're not talking about basic clear the brush from your yard precautions today. No, we're taking a deep dive into the actual materials and construction methods used to build a truly resilient home. Because at the end of the day, this is really about taking control to protect your family and, your biggest investment. When you look at the absolute devastation from recent Los Angeles fires, like the Palisades and Eaton fires, we really have to ask ourselves a critical question. How can we proactively build for ultimate survival right now? I mean, when entire neighborhoods are displaced, we simply can't afford to rebuild the way we used to, and it all starts at the top. The roof is your home's absolute first line of defense against falling embers and insane heat. That makes it the most vulnerable and, honestly, arguably the most important part of the entire structure to get right. To answer that, we'll break down our agenda for today. The Rebuild Challenge, fire resistance ratings, the structural core, protective layers, and finally the complete assembly. All right, part 1, the Rebuild Challenge, getting ahead of the code. Look, we can't just sit around waiting for building codes to catch up to the reality of modern superfires, right? We've got to get ahead of the curve by designing to much higher standards, like Type 3 construction. But here's the catch. When you're trying to push the envelope, the traditional design bid build model often fragments the whole process. It forces you to juggle completely separate architecture and construction firms. It's kind of like a game of telephone. On the flip side, a streamlined design build model seamlessly brings architects and contractors together under one roof. This means advanced fireproofing and innovative techniques are integrated right from day one, not just slapped on as an afterthought. Moving on to part 2, fire resistance readings, measuring endurance. So what's really fascinating about this next concept is that it literally forms the foundation of all fire-safe engineering. We hear the term fire-rated tossed around a lot, but what does that actually mean in the real world? Well, the crucial point here is that a fire resistance rating is definitely not a guess. It is a rigorously tested metric of structural endurance against active burning flames. Organizations out there like ASTM, Underwriters Laboratories, and the International Code Council literally blast these materials with fire. They want to see exactly how long a wall, a floor, or a roof can maintain its structural integrity before totally failing. And for our ultimate survival roof, we aren't just aiming to scrape by and pass the bare minimum. No way. We're aiming for a robust 2-hour fire rating. To put that into perspective, achieving a 2-hour rated roof structure actually doubles the fire resistance rating that's typically required for standard Type V single-family residential homes. Think about that. 2 full hours of extreme heat resistance. That buffer could literally mean the difference between losing a home entirely and actually having a home to return to. Now, pulling off this incredible 2-hour standard requires 3 critical components working together in absolute perfect harmony. You've got your structural elements, your fireproofing materials, and your roof coverings. First up, the structural elements. You can think of these as the bones of the house. Second, the fireproofing materials, so the insulation and underlayment. And third, the roof coverings. That's your external armor, like membranes or panels. It's like a giant puzzle, and if even one of these 3 pieces fails, the entire 2-hour rating fails right along with it. Which brings us to part 3, the structural core, building resilient bones. To actually support that 2-hour rating we just talked about, your house needs incredibly heavy-duty bones. Wildfires can easily reach over 1,500 degrees Fahrenheit. And actually, fun fact, at that temperature, bare steel fails surprisingly fast. So it has to be completely wrapped in intumescent fire spray or up to 2 inches of concrete cover. If you're more of a wood frame fan, it needs to be massive. We're talking at least 5-ply, almost 7-inch thick cross-laminated timber, or specially fire-rated wood trusses treated to retard flames. Alternatively, pouring 6-inch thick concrete slabs offers just unbelievable natural resistance. These are the absolute non-negotiable foundations of a true survival structure. Okay, part 4, protective layers, adding the armor. Once you have the skeleton up, it's time to systematically stack specialized layers to drastically enhance the roof's thermal protection. You usually start with 3/4-inch fire-retardant plywood sheathing. Then you add mineral wool insulation. And what's really fascinating here is that mineral wool is specifically chosen over your standard fiberglass because it has an incredibly high melting point. On top of that, you might pour a 2-inch lightweight concrete topping. Finally, you cap the whole shebang off with a Class A fire-rated roofing membrane. These are essentially heavy-duty specialized plastics or rubbers like EPDM, TPO, or PVC. Together, they act as this massive, multi-layered shield. But hey, the protection isn't just on the outside. On the underside of the roof, so your ceiling, we have to install a double layer of 5/8" type X gypsum board. And to be clear, this is definitely not your standard hardware store drywall. By doubling it up and intentionally staggering the joints, we aggressively prevent any flame penetration right into the ceiling cavity. It literally locks the fire out from the inside. Finally, part 5, the complete assembly. Putting it together. Let's stack our ultimate recipe for survival from the ground up and see what this actually looks like. Imagine incredibly solid CMU block walls meeting a precast concrete or steel roof deck that's topped with 2 inches of concrete. We pack all that with high-heat mineral wool, line the underside with that double-thick Type X gypsum we just talked about, and wrap the exterior top in a Class A fire-rated membrane. Guys, this is a true fortress. This is exactly what it means to build a single-family home that acts as an impenetrable barrier against a wildfire. But wait, there's a catch. Armor is only as strong as its weakest point, right? You could have 6-inch concrete walls, but if a tiny, glowing ember finds even a microscopic gap around a vent or a seam, the fire gets in. So, sealing every single penetration and junction with specialized fire-rated caulking is an absolutely non-negotiable step to prevent breaches. It ensures the fire cannot sneak into the assembly at its most vulnerable joints. As we wrap up this explainer, I want to leave you with this somewhat provocative thought from our sources today. Building above code isn't just some boring technical exercise for architects. It's a profound choice about resilience. With wildfires becoming a harsher and much more frequent reality, are we building just to pass an inspection today, or are we truly taking control to protect our families and build to survive tomorrow? Something to think about for sure. Thanks so much for joining me on this deep dive into the anatomy of a fire-resistant home, and I'll catch you on the next explainer.